Are new environmental regulations putting ships at risk? How can the industry ensure that marine vessels remain safe while cutting emissions? This shipyard in Croatia is helping scientists to improve maritime transport.
Founded 160 years ago, Uljanik is one of the world's oldest existing shipyards. Today, the shipping industry finds itself in a sea of change. New international standards require vessels to reduce air pollution. It's a challenge for builders, as altering a ship's power can sacrifice safety.
The most easy way to do it is to reduce the ship power. But then we come to the problem of the maneuverability, because the less power the ship has, it's less maneuverable.
And what can happen to an underpowered ship in a storm?
For example, if you are caught in a bad weather near the shore, you can fight the current that's heading your way and the wind. You can get grounded, or even in high waves, the ship can get turned and capsize. So there's a big risk of losing human lives.
This cargo vessel, designed to carry 7,000 cars across the ocean, is nearing completion. It's part of a European research project in which scientists are looking for ways to make ships more energy efficient without cutting their propulsion power to unsafe levels.
We can increase the efficiency by reducing ship weight, for example, by installing innovative materials or special propulsion devices that are put in front of the propeller that optimize the inflow of water to the propeller. And in this way, we can reduce the CO2 emissions.
Here in Spain, scientists and engineers are conducting controlled tests in a hydrodynamic center, a large water basin with a computerized wave generator that can simulate ocean and sea motion.
We can determine whether the passengers will have seasickness, whether the structure is sufficiently rigid to withstand the waves, and whether the boat will consume more fuel, so we can try to minimize the pollution.
Scale models with sensors measure the forces that affect ships in adverse weather and help determine ship stability in waves of varying sizes and periods.
Before conducting the tests, we use a special software, and this defines the movement we want to assign to the paddles to reproduce the sea. In fact, the computer controls 60 independent flaps that can generate waves of any kind.
An accurate transfer of model data to full-scale ships is not a trivial task, but by no means impossible, says Professor Papanicolaou, who coordinates the project.
Of course, some uncertainties will remain, but these can be resolved with research experience, so that eventually the prediction of what we're doing for the full-scale ship is reliable enough for practical applications.
With new knowledge in marine transport, the key will be to find the right balance between efficiency and economy, and safety and sustainability.